The indication that there is acceleration is, of course, indication. This is na ay change in speed. Change in direction. Or, this is an or. Okay? So whenever there's a change in speed, there's acceleration, even though your direction does not change, or even though your speed does not change, but there's a change in direction, you are accelerating. Just like turning into a curve at a constant, let's say makita ni mong speedometer sa car, constant, so still you're accelerating because you're changing direction at any instant. And you would feel the force, di ba? Unsa may ma-feel ninyo? If malabay ka on one side of the, di ba? Pag sobra ang turn. And pag kusugid kayo ng turn, ay possibility nga ng mga drifting, di ba? Yan ang ginabuhat sa uban. Very sharp nga turn, or whether very sharp nga turn or very fast nga pag-turn. Okay? Kay kusog man when na may force ana, okay? So, we already discussed friction as a first nga natin is the friction. Of course, this is one of the pinakaano nga contact force, friction. And we now discuss tension. Okay? So, this is just equal to mu n times the normal force. So, friction always the direction of friction depends on the direction of motion. It is always opposite to the direction of motion. Okay? Now, tension on the other hand, this is another what we call contact force. Wala ni sa explicit form. This is like normal force. Okay? It is like normal force nga wala siya formula. Only the tension is the reaction, is a reaction force of a force being applied to usually a string or whatever form of kumbaga pag ina-stretch siya due to the stretching, no? Or possibly compression. So, like for example, na kay kuan ana, no? Exerting a force both sides will cause tension dire. Or exerting a force paana pod will cause compression. Either way, that's actually tension. There is a force experience during a kuan. So tension is a reaction force. Wala siya a form. Wala siya a formula, just like normal force. But for example, you have a mass dire, which is suspended on a string. No, it could be a string or it could be something solid. Solid man ang string. Something wood ba? Or basta as long as naiga connect sa dire. Now of course, the weight is going down. Now, it doesn't fall. Sa ato pa, there's something that equates the weight, di ba? And that force is upwards and we call this force tension. Just like katong unsay contrast sa a normal force. The normal force is the reaction of the surface. Okay, di ba? Mo ni nay weight dire. Oh, you have mass there and there's normal force there in order to oppose the weight. Kaya kung walay force dira, it will collapse, right? So, maurag yapon na siya to keep it in balance. So, in this case, T minus the weight equals 0, right? So, in this case, T is just equal to the weight. Okay? So, this is a very simple tension. So, now, let's have a more challenging example. Natay diri, no? Being hung mass. And let's say this is 30 degrees and this is 60 degrees. So that would mean that this is 90 degrees, no? But it doesn't matter on sini dire. So you have a mass M, let's say this is 100 kilograms. We want to calculate the tension on both strings dire. Okay? So what's the first thing to do? You draw a free body diagram. So ato ni siyang magkuha siguro ng colored chalk kay para mas klaro siya, no? Para mas malipay po itong subscribers. Okay, makita. Okay. Ay, colored chalk. So, the first thing that we are going to do is draw a free body diagram and identify the forces. Now, of course, you have the weight going down.
Imong mic, sir.
You have there the
Di ko madunggan sa
weight.
subscribers, sir. Imong mic, sir. Di ko na madunggan sa subscribers, sir.
Okay. Doon mo na. Reklamo itong subscriber, ana. So anyway, asa ba ito ang... Di rin na natin ibutang itong axis diya. We'll put the axis para na to kay naaman din ang kuan. We will put the x-axis diya. So, this is our weight. And here is the tension due to the string 1. Okay, let's call this T1. Of course, lahi-lahi nga string, lahi-lahi nga tension. Yeah, lahi-lahi po nga color. Let's use green. So you have there. Now, then identify the axis of equilibrium. In this case, since that, okay, mo niyang mass, no? Since that it doesn't move, it's lying there, sa ato pa, both axes is in equilibrium, right? So here, summation of forces along x equals 0. And summation of forces along y equals 0. Now, we have two unknowns here. What we want to know really is what is the tension, what is T1 and what is T2. Now, in order to solve two unknowns, we must also need two equations, diba? So, this is our first equation and this is our second equation. So, may tabo, summation of forces along x. Now, what are the forces along x? Notice that T1 will have an x component and T2 will also have an x component, right? But the weight doesn't have x component. Now, asa padulong ang T1 on the second quadrant, meaning that the x of T1 is negative, right? So, meaning this is now equal to negative T1x. Now, unsa ni siya? This is positive. So, plus T2x equals, okay, mo na siya. And then, this one here for y. Now, T1y is positive. T2y, this is but this is T1x and that is T1y. This is T2x and that is T2y. So, here, tanan sila positive, right? So, T1y plus T2y minus the weight equals 0. Now, remember unsay given ani? Given ang duha ka angle and the mass. That would mean, let's call this our just theta 1 lang sa and this is our theta 2. Now, dapat our answer should be in terms of the given. The given is mass, angle kana. Okay? Now, it seems na ang ato ang nahimo na nung upat. Okay? Right? Na T1x, T2x, T1y, T2y. Ibig ganiya, duha lang. But of course, we can express T1x and T2x in terms of T1 and T2, right? How? Using a triangle. So here we have two triangles here. The first triangle is kani, that kani nga triangle. This triangle is that. You have 60 degrees here. And okay, you have T1x and T1y. In that case, this is the 90 degrees dire. So this is the hypotenuse, no? Hypotenuse. And of course, this is the adjacent and this is the opposite. So, adjacent, opposite. Kaya naman dira ang angle. Okay? Recall your trigonometry. Now, in this case, we can use cosine of the angle, which is 60 degrees, is equal to adjacent. So, T1x over the hypotenuse. What is hypotenuse? The hypotenuse now is T1. That is T1. Right? Kana siya. So, over T1. So, from here, we know that T1 is equal to T1x is equal to T1 cosine of 60 degrees. But actually, cosine of 60 degrees is 1/2. If you do that in your calculator, so sa ato pa, this is 1/2 T1. But you can still use kanina lang gyapon, no? Cosine of 60 is 1/2. So, nanay T1x. How about T1y? Well, again, T1y is the opposite. So, we'll use the fact that sine of 60 degrees is equal to the I think I'll erase na ako ni siya. Anyway, take note naman eh. I'll erase this sa karon na. So, itong equation. Summation of forces along x, this is minus T1x plus T2x equals 0. Summation of forces along y equals T1y plus T2y minus the weight equals 0. Okay. Now let's make use of the fact that sine of 60 degrees is equal to opposite, which is T1y over hypotenuse. We have T1. So from here, you know that our T1y would be equal to T1 sine of 60. But sine of 60 is square root of 3 over 2. That's sine of 60. Okay? Special angle na siya. Well, you can put the decimal, but I don't want to round up as of now. So that, okay, I'll just write this as square root of 3 over 2 times T1. Notice that T1x is now given in terms of T1 and T1y is given in terms of T1, right? How about T2x? We refer now to this triangle here. For that, we have this times 30 man din ni. Man mo nagsaba. Okay. Sorry, this is 30. Okay. $30. Nagsabaw ang tao. 30 degrees. Okay? This is, baliktad niya. This is square root of 3 over 2 and this is 1/2. O bali na siya. Okay? Because, yeah, cosine of 30 is square root of 3 over 2. Now, diri na punta. This triangle here, this is T2. Ay, di natin butang ha. That triangle, this is T2, and this is T2x, and that is T2y. So, naadiri ang 60 degrees. Now, similarly, if we do this one, we would know that, I will leave this to you sa next, at least namin buhato, no? T2x would be equal to T2 cosine of 60 degrees, which is 1/2. So this is 1/2 T2. Yes, cosine of 60 is 1/2. And then T2y, which is sine of 60, T2 times sine of 60, this is square root of 3 over 2 T2. Okay? So we now have only two unknowns. Pag ato na siyang i-plug in diri, no? We plug this kana, and asa pa? This one here. Into this equation, what do you get? Okay? If we plug that into the equation, we now get, for equation 1, okay, let's call this our equation 1, and this is equation 2. So equation now 1 becomes negative T1x. What is our T1x? Kato siya. So this is negative square root of 3 over 2. Okay? Equation 1. Square root of 3 over 2 T1. Right? Plus T2x is 1/2 T2 plus 1/2 T2 equals 0. Tama? From here, okay, from here we can express T1, but this is solving this, okay, ako sa isulat ang equation. Equation 2 is T1y, what is T1y? 1 half T1, so 1 half T1 plus T2y, that is square root of 3 over 2 T2 minus the weight, which is mg, equals 0. Okay? Kunya natin i-substitute ng mg. Now, from here, we can use substitution, no? Solving two equations, two unknowns. So we use substitution. From here, makita nato that T1, and I'd like you to inyo ning i-derive, no? T1 would be equal to T2 over square root of 3. That's what you would get from that. Now substitute this to here. So T1 will be 1 half times T2 over square root of 3 plus square root of 3 over 2 T2 equals mg. We can now solve T2, right? From here, that is 2 square root of 3 plus 2, that would mean 2 square root of 3, square root of 3, so 3. So you would get 1 plus 3 over 2 square root of 3, T2 equals mg. Now, you can immediately use your calculator to solve this. Okay? Kani siya. 1 over 2 square root of 3. But I'm using ani kay para dili ko mag-round off, no? I'm just using some algebraic manipulation. This is 2, square root of 3. So, times square root of 3, may mong 3. So, 1 plus 3 over 2 square root of 3. Naana diri ang ano ha? So, times T2. So, from here, T2 would be equal to, so 1 plus 3 is 4, right? Tama? So, 4 over 2, that would be 2. Nakuha. Okay? So, sa ato pa, this now becomes T2 is square root of 3 over 2 mg, or this is square root of 3 over 2 times what is mg? 100 times 9.8, that would be 980 newtons. And T2 now would give us the value of pila. This is your calculator. Square root of 3 times 980 divided by 2. 848.70 newtons. How about T1? We can now solve T1. If T2 is kani, then T1 would be, in this case, T1 now, T1 now would be, this is 1 over square root of 3 times what is T2? Square root of 3 over 2 mg, right? So cancel. This is just equal to 1 half mg, or this is 1 half times 980, di ba? You get now 490 newtons as your T1. So you have this eventually. Okay? Sabtan? So in this case, what we are interested is actually tension as applied to sample, what if we have this inclined plane here with an angle theta, and you have a mass m, and dahil naka-attach nga string dire. Now, we attach a string here at this end. So, we want to calculate the tension on the string. Okay? So, what would now be the tension on the string? Okay? So, again, this is easy to calculate. This is much easier than the first one. Okay? So, let's draw a free body diagram. What we want is the tension to find is the tension on the string. So, from that, okay, let's identify the forces again. You have the weight, right? You have the weight, and you have tension. On this direction, you have the tension. Now, we will not label T1, T2 because isa lang kabuok, so we'll just use T. Okay? So, in this case, unknown ang T, we only have one unknown, so we will only need one equation here. So in this case, nasa sa x, so purely, we will use the summation of forces along x, right? What are the forces along x? Now, on the negative side, you have minus t. On the positive side, you have here, you have weight x, morning 90 degrees, and you have weight y, dire, di ba? And we know for the fact that if this is theta here, then this is also theta. We already derived that last meeting. So in this case, mahimong opposite ang weight x, right? So it is sine. So meaning, weight x is just equal to weight sine of theta. Okay. So in this case, plus, because this is weight x on the positive side, tama? So plus mg sine of theta equals, this is 0. So from here, we can just say that t is equal to mg sine of theta. Well, if you know the mass and you know the angle, given the angle, you just substitute it there, and you will have now your value for the tension. This is already a working formula. Why? The mass is already given, and theta is already given in the problem. So when you derive the formula, dapat ang final formula must be in terms of the given. Sabtan? Okay? Any question? Okay? Now, let's go to a much more interesting problem. Now, let's analyze the system. This is a pulley here. Now, let's assume that there's no friction in the pulley, so that since this is connected by a single string, then the tension of this string and the tension of that string must be the same. In the more general sense, the tension here and the tension here are different. If we add the what we call moment of inertia dira or tension or friction dira, then the tensions here will not be the same. But now we will neglect that because that will require a more sophisticated treatment of the problem. So that walay friction on this whatever this pulley here. The pulley has also negligible mass, so that the tension diri o tension di ang string pareho. Okay? So we only have one tension. Kung whatever tension here, mo na tension diri. What we want to know is that depending on given nato diri, given M1, M2, angle A and angle B, what is the acceleration? Find the acceleration of the block. So wala ta kabalo asa na padulong dira. Even if bisan pag naani siya values here, we still cannot see immediately kung asa sa padulong. It either will move on this direction or will move on that direction. Nasabtan ninyo? Okay? So, if ana ang mahitabo, then we will assume a movement of acceleration. Okay? We do not know. Walay values ni dire, and even if naay values diha, still, we could not immediately see. Okay? But what we must derive we want to find A in terms of this, of the given here. Okay? So, usay buhaton nato, we will assume a direction of the acceleration. Now, let's put that as our green. Let's assume that the acceleration is going on the in the clockwise direction, right? On the clockwise direction. So what does it mean when we say clockwise direction? First, let's construct a free body diagram for each. Unahon sa nato diri, no? And of course, we also have an axis here. This is the positive x for this, and here this is the positive x diha. Okay, now what are the forces? You have now, again, weight 1, and of course here you have weight 2. Okay? Now, tension is, we'll use red for the tension. The tension now is dire. We call this T. Now, kung dira ang tension dira, in this case, because tension is going in that direction, here, paana siya. So meaning, on this free body diagram, our tension here is going this way. So we have two unknowns here, T and A, right? We have two unknowns, T and A. Well, we can get two equations. One equation from here and one equation here. Pero actually dire we can have two equations here. Because di ba dire natin summation of forces along x and summation of forces along y. But again, the forces along y will not give us anything. Because the motion is purely along x. Y is purely equilibrium, right? Y is an axis of equilibrium. And since we don't need y for that, wala man tayo friction. Unless may friction, we will be needing the y. But since we have no friction here, our motion is not affected by this axis here, by the y-axis ani. So, from here, ang atong usable equation, ang atong equation lang yung magamit is only the summation of forces along x. So, summation of forces along x for the first mass, Fx, and then let's put 1 there. That's the magamit nato dire. And here same again, only the summation of forces along x would matter. Okay? So this is as a first. What are the forces along x? Now again, this is clearly natay triangle there, right? This is a right triangle. So weight x is this. This is weight x and this is weight y. Now atong weight, this is sa ato pa, this is now minus weight x plus t. Now okay, we'll not use t1. Okay, pareho naman na silang attention, right? So t equals what? Now this is no longer 0 because our acceleration here, our object is moving on which direction? It's moving on this direction with an acceleration a. So sa ato pa, this is no longer equal to 0 but equal to ma. Okay? But what is weight x? Well, if this is a, then we already know that that is also a. This angle is also a here. That is also a. So this is just sine of a. This is mg sine a, right? Weight sine a. So this is minus mg, which is the weight, sine of the angle a, plus t equals ma. Now here we can express t in terms of a. Or, okay, if we are going to derive this, we can now have here as t equals ma plus mg sine of theta. Notice that tension now is given in terms of the, okay, sorry, this is mass 1, m1. Okay, so this is m1. Okay, and this is m1. Now, how about our second equation? Our second equation is from the summation of forces along x dire. So, summation of forces along x, but we are now in the second free body, second FBD, no? So, what are the forces here? Again, on the negative, this is minus t. On the positive here, okay, again, this is b here. So, b, this is plus weight x. So, this is mg. M2, okay, this is M2G, okay, M2G sine of B equals what? Again, we are accelerating on this direction, right? Tama? So, this is equal to this is M1. This is M1, M2A. Okay? So, we can now substitute this to that equation and ang mabili na lang is A, tama? So, substituting here dire, so we have now negative of M1A plus M1G sine of A, okay, tama ni, sine of A plus M2G sine B equals M2A. Okay? Now, minus M1A minus M1G sine A plus M2G sine B equals M2A. What should we do? We isolate A sa isa ka side and tanang walay A sa pikas side, right? So, sa'yo mabilin dire. we now have minus m1g sine A plus m2g sine B equals, we have m1a plus m2a, which is again, would be equal to m1 plus m2 times a. And you can now divide it by m1 over m2. Divide this by m1 over m2. We finally have our acceleration. Okay? What is our acceleration? Our acceleration would be, okay, ako ni siyang unahon na. We have m2 sine B minus m1 sine A times, okay, over m1 plus m2 times g. Right? Akong gi-factor out naman ay g, right? Factor out, and then that's why you have this one, no? So this is now my acceleration A. Okay? So, yeah. Okay. Now, let's investigate this further. You can also solve, by the way, you can solve the tension by substituting this one to dira. And you can solve now the tension also. Given naman na tanan, right? Now, let's understand the condition here. Kanus clockwise ang A. Well, if this is positive, this whole thing is positive, then A would be in the clockwise direction. But if this thing is negative, then A would be traveling in the counterclockwise direction. Because, if our preferred if this is our assumed direction, and we get a positive number, then we are right. But if this is our assumed, and we get a negative number, then meaning the true acceleration is going on the other side. Similarly, if this is our assumed, and we get a positive number, mao ni ang true. No? Meaning, if we get a negative number, then it's on the other way around. It's on the opposite direction. Now, in this case, okay, in this case, our acceleration, wala man tayong number. But we know that these are all positive except when the only thing that can make this negative is kani. So here, our acceleration is clockwise so long as m2 sine B is greater than m1 sine A. Meaning that acceleration is here, A is clockwise, meaning we have, we have a clockwise A if m2 sine B is greater than m1 sine A, right? Sabtan? Is greater than m1. Nga naman, because this is positive. How about counterclockwise A? A is counterclockwise if m2 sine B is less than m1 sine A. Now, the block will not move, meaning the acceleration is equal to 0 if what? If m2, okay, sine B, okay, m2 sine B equals m1 sine A. So these are the three conditions, right? So if these are satisfied, then we would know asa siya mo rotate, asa siya mo move. Paana ba siya ang slide ni Redere? Here, counterclockwise siya. The slide is paana, clockwise, clockwise, counterclockwise. Okay? Sabtan. Now, if you put some values there, all you have to do is, you can now substitute na ninyo dire sa kuan, right? Because these are all given. Given ang M2, B, M1, A, and so on. Nakuha? Okay. Now, how about we can use this result in order to solve a special case. I will not be solving this. I want you to solve this on your own. Pero, ang akong isolve is that I will show that, using a special case. Okay, I'll erase this one now. We have a special case in which our special case is this. We have this table here. We have M1. Again, same sa string, same assumption. And we have M2. In this case, we can now calculate our acceleration. And I'm going to show you that it's not possible to have a counterclockwise acceleration here, in this case. Now, how are we going to transform this case into that case? Well, you can arrive at this by setting. Remember that as A mo ana, di ba mo approach sa dito, meaning in this case we have A equals 0 and B becomes ana, di ba? So B is 90 degrees or pi over 2 or 90 degrees or 90 degrees. So we would have that formula. So in this case, our acceleration, we are going to use this one. A is equal to m1 sine B. What is sine of 90? Sine of 90 is 1. So this becomes m2 minus, what is sine of 0? Sine of 0. Sine of 0 is 0. So sa ato pa, wala ni siya, minus 0 over m1 plus m2 times g. Here, this is our acceleration nga makuha ani nga case. And we can see that our acceleration is always positive. Meaning that it always goes in our assumed clockwise direction. It cannot be negative because this cannot be negative. Imposible na siya nga moana dito, right? It's impossible. Okay? Unless tagana ni mo initial andra. And also you can calculate the tension here by, okay, substituting this one sa katong kuan. Sabtan? So this is a special case. Now, practicean ninyo that I want you to derive this special case by doing the same thing that I have done for that case there. Arguing this one, doing this, buhatan yung free body diagram and free body diagram dire. Okay? And, okay, you should be able to arrive that A is equal to ani for your practice. Okay? This is aron, of course. Okay? Hadlok man dayon yung mata mo. Okay? Ha? Na-tension dayon mo? Na-tense. Okay? Nasabtan. So, video. You can watch the video again. And of course, every time you watch the video, you click like. Ha? Okay? Ha? Mo? Okay, so, ano man gud ang ginabuhat na ako, class, in order for you to, I'm not actually fond of putting numbers. Because in putting numbers, you're going to memorize formula. You're going to memorize solutions. I want you to get the concept mismo. Kana ganing bahalag, maybe dili ka ka-solve, maybe dili ka kabaluan, pero kabalo ka, unsaon na siya pag-analyze. Mas importante na siya. Like, for example, how do we apply this to biological system? Well, of course, when you carry something, di ba, tension na dira, right? Kanang, okay, kargahon ba mo ng, whatever, kung say kargahon, kani siya, di ba? Oh, kani kay, be? Okay. Ang gawas akong muscle, oh. Nga nang mugahi maning muscle diri. Okay? Right? Now, I'm experiencing a tension. Okay? Oh, okay, di ba? Oh, palit ang galaksan na niya. So, anyway. So, di ba? The tension is actually being sa akong muscle. Kung sa'yo ginabuhat sa akong muscle in order to equate the force. Okay, mamaul na, pamaulan ko niya. Okay? Okay na ni kay sa gym ang gani nga mas nindot na yung portable yung uyab no kay pwede rin mo diri nay kuan dira daghan galakaw mo ba nya ipalhin mo siya diri ka. Nga gamay nga uyab ang tawagan na kay portable. Okay. So, yeah. Asa man ta naganog tension, whenever you carry something, you are, ang tension diri, there's building tension diri, right? And kanang tension, ginaano na sa atong muscles, right? Now, of course, naay kaya lang a certain force nga kaya sa atong muscles, depende sa iyahang capacity. Okay? That's why, sa gym gani, okay, kanaganing uban nga, dili ka basta-basta di ba? Like, kanang iana nimo, pwede mabali imong likod, meaning dili makaya sa imong body. Because mo break na siya. Kani, dire. The strings can break. Whatever is this, kung sige attach mo it can break. Pag kusog na kayo ang tension. Actually, what breaks is not the force but the pressure. Pero wala pa man tanabot sa pressure. Okay? Okay, nasabtan. So, nasabtan? All right. Any question?